So hopefully my screen is visible. Um, Hello everyone, I welcome you all to the fifth live session of the NPTEL course Basic Environmental Engineering and Pollution Abatement. This course is instructed by Professor Prasenjit Mondal from IIT Roorkee. Uh, and my name is Chaitra Borkar, a Ph.D. scholar from Indian Institute of Technology, Delhi, and I will be conducting this live session. So some general information about these sessions, that these sessions will be conducted every week on Saturday from 3 to 5 p.m. and the links have been shared with you all. These live sessions are recorded and the recordings will be made available to you through my YouTube channel. So let's start with the lectures that were conducted in the week 5. So the lectures in week 5 were all about the control of air pollution. So, firstly, in lecture 21, the different types of air pollutants which are present in the atmosphere, they were discussed. So, they can be gaseous components such as um, carbon monoxide, oxides of nitrogen, oxides of sulfur, or particulate matter, which are solids or liquids suspended into the air. Um, Next, the removal of these particulate matters, the techniques, different techniques and processes were discussed. So, one of the processes is the separation of the particulate matters in the air through the effect of gravity. So, in that, two different equipments, one is gravity settlers and settling chambers were discussed. So, this image is for gravity settlers and this is for settling chambers. So to reduce the vertical distance for settling, these plates are introduced into the settling chambers so that uh, kindly mute yourself, please. So different plates are in a number of plates are introduced so that the vertical distance for settling reduces so that more particles can be collected. Um, Next, for lecture 22, the continuation of removal of particulate matters was there, and in that, electrostatic precipitators were discussed. In the electrostatic precipitators, they can be of two types, which is one is parallel plate, which is shown here, and another one can be wire and pipe precipitator. So in this, the use of electric charge over the particles the is I mean exploited. So because of this electric charge, you can have an oppositely charged plates present, and these particles will then get attracted towards these oppositely charged plates, and so they will be separated from the air. And the collection efficiency was also discussed. In Next, the fabric filter. Kindly mute yourselves, please. Please mute yourself. Next, in the removal of particulate matters, fabric filters were discussed. In that, there are a number of bags of filters through which the air is passed, and in the fabric of these filters, the particulate matter get entrapped. And the separation mechanism can be through inertial impaction, interception, or diffusion. Usually, most of the separation is done through inertial impaction and interception, and a less amount of separation occurs through diffusion. The collection efficiency for the same was discussed, and to clean these fabric filters, because as the particulate matters get deposited onto the fabric, the pores may get clogged. So then the efficiency of these fabric filters decreases. So to clean these fabric filters, you can use a number of mechanisms such as shaking, so that the particulate matters because of the shaking can be removed from the fabric, or reverse air. So in reverse air, you what you do is, from where the air is coming out, from there you input the air. From there you input the clean air, so that these particles which are in the pores, they may get removed. And the next is the pulse jet. So you, for a short duration of time, you send a pulse of high velocity air, and because of this high velocity of air, and this short duration, the just a minute. Chandan, you have raised your hand. Is there any question you have? If you don't have any question, then okay. I'll continue with my session. So, uh, I was discussing about pulse jet. So, because of this very short duration of very high velocity air, the particles clinging onto the fabric, they get removed. And this is this is for the normal operation of fabric filters, so that there's a gas which is coming in, and these are fabric filters, and uh, and the particulate matter get clogged onto, means get stuck onto the fabric, and the clean air is coming out from here. And for pulse jet, you can see that the reverse direction of flow is there. So pulse jet is introduced here, and these into the filter bags, and then the particulate matter does gets removed from here. The types of fabric filters can be woven, felted, or membrane type. And the air to cloth ratio is a parameter, a design parameter which is essential for fabric filters. Was also discussed about. So it is basically. Please mute yourselves. I request you to kindly mute yourselves, please. Please mute yourself. Excuse me, can you hear me? Kindly mute yourself.
मैडम वो ज्वाइन करके शायद कहीं गया है.
Okay, just a minute. I'll just continue with my class. Okay, so in lecture 23, the continuation of removal of particulate matters was there. So in the next type, so we saw up till now, there is separation through settling due to gravity. Then you have some filtration methods are also there, and now this is a cyclone separator. So it utilizes the centrifugal force, and its centrifugal force of the imparted to the air, and because of the centrifugal force, the particles will get separated from the air. So in this is a setup, this is a the equipment, cyclone separator, which is used to separate the particulate matter. So the dirty fluid enters from this tube, which and because of this placement of this tube, the air gets tangent, it gets centrifugal force. So because of that centrifugal force, the centrifugal force has the tendency to impart force outwards in the radial direction. So, and because of that, the particulate matters. Just a minute. the particulate matter are impacted onto the wall, and then they are collected, and they slide down through the wall, and they are collected down here. And this air, then this vortex which is created, then this air forms another inner vortex, and this reaches upwards, and the clean air comes out from here. So there is a tussle between the centrifugal forces and the drag forces, and also the radial and tangential component of velocity are introduced here. Also, the cut diameter or the cut size is basically um, uh, the diameter of the cyclone separator, so that there is a 50% removal efficiency, and also the removal or collection efficiency was discussed in this case. Next, the removal of gas, a combination of gas and particles were discussed, and in that wet scrubber is generally used, and it can be of different types. It can be a spray tower, in which the gas is there is a column in which a gas is introduced from bottom, and there are spray of the liquid at the top, and there is a contacting between the liquid and the gas, and because of that the particulate matter get dissolved in the liquid, and the particulate matter is thus separated from the gas. Another can be centrifugal scrubber. So it utilizes this centrifugal force. Next can be packed bed column. So you can use packing, and so that there is better contacting, and thus the particulate matter can be removed from the dirty air. Another can be plate or tray column. So different arrangements of tray in the vertical height of the column can be used for, also it is better for contacting. Another can be venturi scrubber, which is shown here. So because of this venturi structure present here, the air gets high velocity, and it kind of forms a vortex here itself, and because of this vortex form, the separation of particulate matters from air is achieved. Next is the effectiveness of scrubber was discussed. Uh, the removal of gaseous components was also discussed, and in that, firstly, absorption through liquids were discussed. So, the absorption, you first need to select a solvent basically, and this absorption can be chemical in nature, physical in nature, or physical chemical in nature. Next was the other than absorption, it can be adsorption techniques. So you can adsorb the harmful gases present in air onto some solid materials, and these solid materials can be, for example, activated carbon or silica gel or molecular sieves. Um, and but the adsorption techniques are usually less used. Next is the control of specific gases components. So there are some components in air which have very detrimental effect to the environment. So specifically these control of the emission of these gases is discussed here. So first is SO2. So SO2 can be removed through wet and dry methods, and mainly Rhine-Left adsorption process was discussed here. Uh, for NOx, the for NOx, if it is, I mean, NOx is usually, as we know, generated from a combustion at high temperature. So if there is some way to reduce this temperature, so reduce this temperature, so that NOx is not generated at high temperature, so less NOx will be generated. Or there are other techniques for in case of automotive vehicles, there is a term called exhaust gas recirculation. So, if we recirculate the exhaust gas, it can also decrease the temperature of the engine, so that less NOx is produced. But it can also have this flip side effect is that it can also introduce more particulate matter, because exhaust gas may have more particulate matter. So there should be some balance in how much exhaust gas you want to recirculate, so that there's a balance between particulate matter as well as the NOx control. Another can be so NOx can also be controlled through absorption techniques, and catalytic reduction. So in the catalytic reduction, you can use certain catalysts on which selectively you can reduce NOx. So NO will be converted to nitrogen. So reduction of NO takes place, or it can be non-selective, so that both NO and NO2 can be reduced to nitrogen. Next was a CO2 removal. So chilled ammonia system is basically used. So ammonia, when it reacts with CO2, it forms ammonium hydrogen carbonate. And when this reaction occurs, the CO2 is removed from the air. Next, lastly, the air purifiers, which are basically used to improve the indoor air quality, were discussed. So, either they can be active or they can be passive. So, passive are basically, I think, filters. And next, we will now discuss the sample questions based on the assignment 5. So, first question is, VOCs are a large group of chemicals that are found in many products we use to build and maintain our homes, such as perfume, paints, hairspray, cleaning agents, etc. The full form of VOCs is, can anybody give me the answer for this?
Second option.
Second option, yes, correct. So, VOCs are volatile organic compounds. Uh, Next, we go for the second question. Second question is, which of the equipment is not used for the removal of particulates from the gas? What will be the correct answer here? I mean, which is not used for removal of particulates from gas? Can anybody give me the answer for this as well?
Ball mill.
Yes, correct. You are right. Because ball mill is used generally for size reduction of the solids. So the other three we have already discussed that it can be used. So gravity settlers uses gravity. Wet scrubbers are basically they can remove particulate matter as well as gas components. And fabric filters are also used for the removal of particulate matter. So yes, ball mill here is the correct option. Third question, identify the missing force in the following depiction of force balance on settling particle. So here you are given a particle, and it is falling under the effect of gravity, but it is also surrounded by some fluid. So what different forces will act upon it? So one will be force of gravity, the other will be, it's shown here, drag force. One more force will be acting on it. So which force is it? Is it the kinetic force? Is it the buoyancy force? Is it the frictional force, or none of these? Can anybody give me the answer for this?
This is buoyancy force.
Buoyancy.
Yes, yes, correct. Buoyancy force is the correct answer. So when a particle is surrounded by some fluid, it can be liquid or gas. So it basically displaces some volume in that fluid, and because of that, some force is acted upon by the fluid onto the solid, and it can be it's so it creates an upward motion. So this force is the buoyancy force. So yes, correct answer is buoyancy force. So this is the calculate the overall efficiency of gravity settler for the dust sample. Data given in the following table. So these are the different types of these are the different cuts of the particle size, and their weight per 100 gram is given here, and the fractional efficiency is given here. So we need to calculate the overall efficiency. So the formula for overall efficiency is just a minute. So the formula for overall efficiency is summation of all fractions, uh, the weight fraction multiplied by the fractional efficiency. So what we do here is we sum all these fractions, the weight of these fractions into the fractional efficiency. So this Wi is basically uh, mass of mass or weight of the fraction per the total mass. So here the total mass is 100 gram and the weight of the fraction is 2. For the if you see for the first fraction it is 2. So mi by m for first fraction will be 2 by 100, so it will be 0.02. And if you multiply it by 0.02 by into 1, so this will be for first fraction. And similarly for all the fractions we need to do this. So multiply the fractional weight by the into the fractional efficiency and sum it all. So you will get the overall efficiency. So here is the solution basically. 80.9 comes out to be the answer. So what you need to do is eta will be uh, 0.02 into 1 plus 0.03 into 7 plus and so on. I mean, you get the idea how to do this. And last will be, it will be zero point 0.1 into 99 plus 0.05 plus 0.05 into 100. So you get the efficiency as if when you sum all this, you get the efficiency as 80.9%. Okay, so next question is typically a value of air to cloth ratio of dust loading for fabric filters is. So in lecture 22, the typical values of air to cloth ratio is given and it is the second option 1.5 to 3.5 meters per minute. So the correct option is the second option. Next question is a MSW based power plant is emitting 55,000 meter cube per hour flue gas. It is proposed to install an ESP with a collection efficiency of 96.8%. Calculate the total area of the collection electrodes. Drift velocity of the particles has been determined experimentally as 0.13 meter per second. So the collection efficiency of the electrostatic precipitator, it was discussed in the lectures as 1 minus exponential. So AC is the collection area of the plate. This is the flow rate of the air and this is the drift velocity. So 1 minus exponential of this term is the collection efficiency for electrostatic precipitator. So as you can see here, the flow rate, which is Q, is 55,000 meter cube per hour. And the drift velocity given here is, it is in in meter per second. So you need to make first the units consistent. So for that we convert this meter cube per hour into meter cube per second. So what we do is we divide by 3600 seconds because 1 hour contains 3600 seconds. So it will be meter cube per second. Uh, and then we basically, so we are given the efficiency as well. We need to find out the collection area. So it can be calculated as 0.968 is equal to 1 minus exponential of um, we don't know the collection area, and drift velocity will be 0.13, and this will be 55,000 by 3600. So if you solve this, you will get the answer as the last option, which is 404.3. It comes out as 404.5, but it's near to this value, so 404.3 is the correct answer here. Next question, fabric filter, the Hind's correlation could be given as, so this is the relation for Hind's correlation. Uh, and here they are asking what is this psi value. So is it the adherence factor or collision factor or Stokes impaction parameter or fiber solids fraction? So can anybody give me the answer for this? Is Can anybody give me the answer for this as well? So the answer for this will be Stokes impaction parameter. So you can see in the relation itself it is given eta of impact. So this psi will be Stokes impaction parameter. Next question, which of the following option appropriately connects the adsorbent with type of impurity adsorbed as provided in the table below? So for silica gel is usually used for adsorption of a number of components. It can be silica gel. The fourth option is correct for silica gel. Next is the activated carbon. Activated carbon is usually used to adsorb methane and carbon dioxide. So B will be connected to 2. Next is molecular sieves. Molecular sieves are usually used to adsorb methane, carbon monoxide, and nitrogen. And activated alumina is generally used to capture water. So the correct answer is A4, B2, C3, and D1. Next question, what is the aspect ratio for a 5-field electrostatic precipitator having collection plate heights of 30 feet, collection plate lengths of 9 feet, and a precipitator width, it is given as 50 feet. So here they are asking for aspect ratio, which is basically L by H, so length to height. So here you are given 5-field electrostatic precipitator. So you have 5 fields, and length of each field is 9 feet. So 5 into 9 will be the total length, and divided by the height, which is 30. So you get the answer as 3 by 2, and the aspect ratio comes out to be 1.5. Next question.
Excuse me.
Yeah.
In eighth
Mm-hmm.
question, the last one,
Mm-hmm.
we use silica gel in desiccators as well, right? So it's
Huh.
for the adsorption of moisture,
Yeah,
which
yeah.
is water.
I mean, but mainly activated alumina is an efficient one. Plus, silica gel. All the other three, if you see, they can't be used for this fourth option. Not all of them are efficient to absorb ethane, propane, butane, and heavier hydrocarbons. Heavier hydrocarbons, so you can't even. I mean, it's very difficult to absorb on these. So you need to see that silica gel. All of these the components, which one absorbs. So silica gel is usually used for that. So I know I get your point that silica gel is used to absorb moisture as well, but you need to see the other options as well. Do you
Okay.
get my point?
Yes.
Okay. So last question, collector efficiency of scrubber is given by, so this is the expression given, and they are asking what is the K and the psi terms here. So can anybody give me the answer for this? We already know the half answer already because psi was already discussed in previous questions. So psi will be impaction parameter, and the other one you need to know. So it will be empirical factor. So the correct answer is psi is impaction parameter and K is empirical factor. So these were the questions. Any doubt does anybody have? So if there are no doubts, I will go ahead and end the session for today. Does anybody have any doubt?
Ma'am, can you show me the slide number 22? Yeah, slide number 21.
Slide number
21.
21. Okay, just a minute.
Uh,
Do you have any question about it or what is it? Slide number 21? I don't have slide number 21.
no, no, the first slide of your presentation,
Acha, okay.
actually,
Lecture 21 you're saying.
lecture 21.
Ha,
Actually,
okay.
yes, yes, yes. Actually, I missed this slide.
Okay, okay. So do you
Okay,
have
no,
any
thanks. I, uh, I take the screenshot. Okay.
you will be given these lecture notes as well as the videos are shared with you. So you can go through it. You don't have to take screenshots.
Yeah, yeah, yeah. Okay.
Okay, so anything else? Does anybody have any other doubt? If not, then I'll go ahead and end the session for today. So thank you everyone for joining.